Hello, Sugar Gliders. Welcome to Chapter 6, Lesson 6. We're going to look at our fourth property of math, the distributive property. The distributive property combines addition and multiplication, and it can be helpful when we're doing mental math, when we try to do it in our head instead of using a calculator or paper and pencil. So our first example is 6 times 38. We're going to use the distributive property to do it mentally. I'm going to have to write it all down to show you what I'm thinking, but typically we would just be thinking all this in our head. So when we have 6 times 38, I'm going to break up this 38 into 30 plus 8. So what I did here was I wrote 38 as 30 plus 8. It still has the same value as 38. My next step, I am going to use the distributive property because I'm going to take the 6 that's on the outside of this parentheses, and I'm going to take the 6 times the 30, which I'm showing you here, and I'm also going to take the 6 times the 8, which I'm showing you here. So that's where we've just used the distributive property. So now I can look at this as two separate problems. 6 times 30 is 180, and 6 times 8 is 48. So I should have been able to multiply 6 times 30 mentally. So what I did was I multiplied mentally in my head. And then the last thing I'm going to do is add those numbers together. Okay, so when I add 180 plus 48, I can do it in my head. I know these numbers aren't the easiest numbers to do, but 80 plus 48 I know is 128, and then I tack it onto the 100 and I get 228. All right, let's look at the next example. Find each product mentally using the distributive property to get it up to a nice round number, and then take that 10 away. You may or may not know what I'm talking about. We'll talk about it in class. All right, example 2. You can also use algebra tiles to model expressions with variables. So I know you don't have tiles in front of you, but I am going to let this long tile be an x, a variable that we don't know what the number is. And I am going to let this blue one represent the integer 1. Okay, so if you see that, that's a 1. All right, use algebra tiles to tell whether 2 times 2x plus 1 and 4x plus 2 are equivalent. Do those two mean the same thing? Well, let's take a look at 2 times 2x plus 1. This 2 means I have two groups of 2x plus 1. So I'm going to show you what 2x's look like. 2x's look like this. Here's 1x. There's 2x's because I said that's my model of an x variable. Then I have plus 1, and that 1 is simply an integer. So that's what that looks like. That's 2x plus 1. Now it says there's two of them. That 2 on the outside means I have two of those groups. This is my 2x plus 1 in the parentheses. I have two of those. So I'll do another one. 2x's plus 1. Okay. So that's what's inside my parentheses, two of those groups. Is that the same as 4x's plus 2? Well, if I counted them, if I put them all together, let me count. 1, 2, 3, there's 4x's, just grouping them together differently, plus there's a 1 square, which is an integer 1, and another one, which is the integer 1. So does 2 times 2x plus 1 and 4x plus 2, are they equal? Well, here's 4x's plus 2. So the answer is yes, they are equal. So those two expressions are equivalent. So we get to visualize what that would look like using algebra tiles. All right, let's look at another example using algebra tiles. Tell whether 3 times x plus 1 and 3x plus 3 are equivalent. So let's remember, an algebra tile, this would be an x, and one little square would be the number 1, integer 1. So here, this means I have 3 groups of this. Okay, so my first group would look like this, x plus 1. And it says I have 3 of those, so I'm going to make another group of that. An x plus a 1, so there's 2 of those groups. And then my third group would be an x plus a 1. Okay, so this represents that. And let's see, is that expression equal to 3x's plus 3? So if I were to draw 3x's, my x's look like that. 1, 2, 3 x's plus 3, the number 3, here's the integer 1, 2, 3. So if I looked back and counted, I can see I have 1, 2, 3 x's on the left, 1, 2, 3 on the right, and 1, 2, 3 blue integers on the left and 3 on the right. So yes, they are equivalent. All right, now we have a visual using variables. Let's take a look at the distributive property to rewrite 2x plus 3 without our tiles. So if we were to distribute this 2, we can say 2 times x plus 2 times 3. That would equal 2x plus 6 after I've multiplied that out. Okay, let's take a look at the second example.